Okay, we're going to go ahead and run through the exam review practice problem, the second one, which is one that's got an object hanging from ropes. Okay, so let's go ahead and crank through that one. We're going to do this problem way quicker than the last one. Okay, we're just going to zip through this one without talking through every step in excruciating detail. So here we go. So this problem says, hey, there's looks like a cylinder hanging from some strings. Okay, and so the picture looks kind of like this. Uh-oh. Marker's not so hot. Let's try this one. You got the cylinder, and it's hanging from some strings. One of them is kind of pulling up at an angle like that. One of them is kind of going at a downward angle, like that. Oh, I drew my picture incorrectly. Oh, man. Oh, man. Oh, man. Okay. Actually, the strings are like this. They kind of come together like a little knot there, right? And then this cylinder is attached to that string. There we go. Okay, that's our picture. Okay, they go ahead and they give us some angles. Okay, they tell us that, let's see here, there's like a ceiling and a wall here, right? And they tell us that this makes an angle with the ceiling of 65 degrees. And this one makes an angle with the horizontal of 20 degrees. Okay, so both of these we're showing the angle that they make with the horizontal line. All right, and they go ahead and they also labeled the tension in the ropes for us. They said we're going to call this tension in this rope T1, the tension in this rope T2, and the tension in this rope T3. Okay, so we're going to use their names. Okay, we got to use the names they give us, and that's okay. Those aren't bad names. And they tell us one more thing. They tell us, hey, the tension in this right rope here, okay, they tell us that tension is 112 newtons. So they tell us the value of T2. That's given. That's it. That's all they tell us. And our goal is to solve for every force and to solve for the mass of the cylinder. So we can do that. We can do that. Okay, so here we go. Running through. First step in solving a problem, besides having a sketch, that's usually the first step, but they gave us a sketch. First step is going to be force diagrams. So first, before I can even jump into that, I got to say, well, what's the system I'm going to analyze? In this case, you say, well, now we want to find the mass of the cylinder, so the cylinder is going to have to be a system, right? But I can see that there's these ropes here tugging up here, and they give us the value of this rope that they give us the value of, it's not even touching this thing. So I'm going to have another system. I'm going to make this knot where the strings are all tugging on each other, ropes are tugging on each other, make that the system. So I'm going to have two systems, one the knot, one the rope. Each system I'm going to do a separate force diagram for. Okay, so I'm going to have two systems. Here we go. First, the knot. I'm going to represent the knot with a dot. Okay, so that's the knot, and I'm going to have the cylinder. Okay, here we go. Forces. So first, we'll start with the knot. Ranged forces. You say, well, the only ranged force we're worried about is gravity, and you say, hey, gravitational force in the knot. The thing is, how heavy do you think that little knot is? Well, it's so small mass. The gravitational force will be so small, we can neglect it. So we're going to neglect the gravitational force on the knot. Okay, small enough we don't worry about it. Now we go to contact forces. What's touching it? Like, well, there's these three ropes all tugging on it. And those ropes are stressed, so there's tensions. And they gave us the names for them already, so I'm just going to go ahead and drop those in. Tension always goes along the rope, and it always pulls, so it goes away from the system. So I'm going to have a tension force pulling up like this, called T1. Sure. I'll have a tension force going down to the right here, we're calling T2, and a tension force going straight down, called T3. There's nothing else touching the knot, so that's it. That's my force diagram for the knot. I can go ahead and draw in angles and stuff. I'll come back and do that in a minute if that's okay with you. Okay, now the cylinder, you'll say ranged forces. There's a gravitational force. That's G. Contact forces, what's touching it? The only thing touching this is this string. Is the string being stressed? Yeah, sure, gravity's tugging it down against it, so that's a tension. They already gave us the name for the tension in that rope. It's called T3. Hey, in this rope, along the same segment of rope, the tension's the same all the way through. The tension at this end tugging on the knot is the same size as the tension tugging on this cylinder. That is something to know. The tension's the same along the rope. Okay, so there we go. That's our forces. The next step in doing a problem is to choose coordinate axes. Again, the rule for which way our axes go is the first axis goes along the direction of motion, but nothing's moving here. It's all sitting still. And that means technically we can use whatever axes we want, but it's traditional generally to use up, down, left, right. Okay, we typically call those what? Left, right, X, up, down, Y, X, Y axes. It's traditional to do those. The nice thing about those is you know you're going to have a gravitational force and it's going to be right along one of the axes then, so that at least you won't have to split that one up. So we'll do X, Y axes. So I'm going to go ahead and show those here on my sketch. And I'm always going to identify which way I want to call the positive directions. Again, it's traditional to call right and up positive, so we'll go ahead and do that this time. So this is where we're assigning directions. And now we say, okay, any force that's going along more than one axis has to get replaced by components going along those axes. So running through T1, you say, hey, using the words up, down, left, right, which way is T1 pulling? And you'd say it's pulling up and left. So I got to replace it with a chain of arrows that starts where it starts, ends where it ends, going up and left. And so running through, you'd say, hey, I might draw that like this, up, left. Now, here I have this triangle. Do I know any of these angles? They said the angle the rope makes with a horizontal is 65. Here's that tension making an angle with a horizontal. This is the 65 degree. This side's adjacent, so I'll be using trig function cosine, hypotenuse times the cosine. So it'll be T1 cosine 65. This side will be T1 sine 65. Over here, I've gone ahead and I'm using my, this guy, you say, this guy's pulling, using the words left, right, up, down. You'd say T2 is pulling right and down. And so I got to replace it with a chain of arrows going to the right and down. Do I know any of these angles? They told me the angle it makes with the horizontal line is 20. So the angle this force makes with the horizontal line, because the force goes along the rope, that's going to be the 20 there. So this side's adjacent. T2 is the hypotenuse, so I'll use cosine. This will be hypotenuse times the cosine of 20. This will be hypotenuse times the sine of 20, right? Okay, T3, it's just going up and down. That's along one of the axes, so I don't have to put split components. Same thing with T3, FG. That's it. That's all our components drawn. Next, we can oftentimes people will ask you to show congruencies. So you can say, okay, congruencies, that's forces that are equal and opposite. You'll say, take a look at this knot. How many forces do we have along the x-axis? 1, 2. Just T2 cosine 20, T1 cosine 65. Hey, if I got two numbers that add up to 0, they've got to be equal and opposite. Drunk, 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 drunk. Those are balanced. Let's talk about up and down. How many up and down forces do we have? 1, 2, 3. And if I got three numbers that add up to 0, do any two of them have to be the same size? No. So I can't draw any congruencies there. What about this system? I've just got two forces balancing out here. Two forces adding to 0. They must be equal and opposite. So I can go, chirp, chirp. Oh, and by the way, T3, T3 are the same, so chirp. That's all the congruencies I can draw for this problem. Moving on. Next step. Once we've got our force diagrams done and choose axes and have components, the next step now is to go to the big formula for the unit. That's sum of the forces equals 0 for systems in equilibrium. The forces add up to 0 for each axis. So I'm going to write that formula. How many times can I write the sigma F equation in this problem? 3 times. I can do it once for each axis for each system. So I can do horizontal axis and vertical axis for the knot and vertical axis for the cylinder. So I have 3 equations. Here we go real quick. I'm going to start with the knot. I'll do the sum of the forces in the horizontal axis add up to 0. And then I'll do the sum of the forces in the vertical axis adding 0 for the knot. The cylinder, I'll go ahead and do that one down here. The sum of the forces in the vertical axis have to add to 0 for the cylinder. Okay, let's go ahead and I'm going to write these equations using the labels from the diagram. Notice once again, our labels, the only numbers we're using are angles, right? Okay, we want to use variable names first. Even though they told us the value of T2 is 112, Please don't label this 112 cosine 20, 112 sine. Use the names. Okay? Here we go, running through. Some of the forces in the x. We're calling to the right positive, so do forces to the right minus forces to the left. This is where we finally put plus or minus signs on the things. It's in this step. Forces right minus left, so it'll be T2 cosine 20 minus T1 cosine 65. And that's it, that's the only horizontal forces. That equals 0. T2 cosine 20 minus T1 cosine 65 equals 0. This minus this. Now do up and down forces for the knot. Going up, I've got T1 sine 65. Going down, I've got T2 sine 20 and T3. So forces up minus forces down. T1 sine 65 minus T2 sine 20 minus T3. And those should add to 0 because we're in equilibrium. Now the cylinder, up minus down, T3 minus FG equals 0. That's it. Those are our 3 sigma F equations for this problem. Again, we always will ask you to show us the sigma F using the labels from your force diagram. That's the way we'll ask it. Okay, every time. Because again, this shows your understanding of the physics to get to this point. After this point, there's very little physics. It's almost all just algebra from here on out. We want to check your physics ability. And so make sure you understand what's going on. And that's it. Okay, now what? Well, now we're just going to do a ton of algebra to solve this. Do we know the values of any of these variables that are in our equations? And you say, yeah, we know one of them. We know that T2 is 112 newtons, and that's going to be enough. With that, we can solve the whole shebang. You say, look, I'm just going to show you how we're going to do it, and then I'll just show you the math real quick. First, we know T2 is 112, so that'll go anywhere we see T2. So right there, we'll have the value of T2 is 112. Now look, if I know that variable, there's only one other variable, T1. Now I know T2 and T1 once I solve that, right? If I know T2 and T1, look at this equation. I'll know T2 and T1, I can solve for T3. That's the only other unknown in that one. Once I know T3, look, T3, I can find FG. And I'll have the gravitational force, and I'll have solved for every force. That's how this is going to work. I'm just going to run through the math now real quick. I'm trying to solve for T1, right? Because I know T2, so I'm just going to get T1 by itself. Rearranging this mess, I would get T1 equals T2 cosine 20 over cosine 65. Punch in my values. T2 I'm told is 112. Okay, punch this in my calculator, and I get a value for T1 of 249 newtons. That's T1 solved for. Now that 249, I can put it in here where it says T1. I know T1, I know T2, I'm trying to solve for T3. I'll just add T3 to the other side, right? Add T3 to both sides, and then that leaves T3 by itself where I want it. So T3 equals this. I know T1, T2. Put those values in. 249 for T1. T2, we were told, is 112. Plug in my calculator, doomby, 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 and I got a value for T2. T3, sorry. T3 of 187.4 newtons. Now I know T3, I come to this equation, look, add FG to the other side, T3 equals FG. Put in my value for T3, 187.4, and that's it, that's FG, right? They're the same size, because they're balancing out, only 2 forces there. Okay, so I've got FG, that's all my forces, but there was one last thing they want us to solve for. Okay, that's all our forces, but they wanted to know what's the mass of this cylinder. Okay, and you say, well, I know the gravitational force, also known as the weight. Can I find the mass? And you say, yeah, we've got a relationship for that. We know that the relationship between mass and weight. We're going to use our formula. Gravitational force is 9.8 newtons per kilogram times the mass. Okay, so to find the mass, I'll just divide both sides by 9.8. Leave my gravitational force divided by 9.8. Is it okay if I don't use the units when I get into the calculation? Yeah. So you say, so the mass is going to be that force, 187.4 divided by 9.8. punch that in my calculator, and I got a mass of 19.1 kilograms. Again, mass is always in kilograms. And that's it. That's everything solved. That's that free response problem. All right. Hey, on the cumulative exam, right, we're going to expect you to be able to crank through 3 of these and do 6 free response questions in the time allotted. Okay, so you want to have practice with these. Again, recommend going back, trying other problems from homework from the past. Make sure you can do them from scratch on your own. If you want some more practice problems, there are some in your textbook. But that's a little bit trickier to find ones because they mix forces in equilibrium, forces not in equilibrium in the same chapter. And so I don't usually recommend using the textbook yet until we have that unit. But yeah, if you come and talk to me, I can point some problems out for you. Okay, that's it.